All right, so we're going to talk about the 2.2 set today. Start with question 13. Question 13 is the parent function. How are we going to graph that? Well, I would look at it, and I would not look at it in standard form, but I would look at it from a vertex form. Y equals a x minus h squared plus k. All right? When you do that, you identify a, h, and k, not b, h, make that an h. All right? A, what is a out of this? A is 1. H, there is no plus or minus, so h is 0. K, there is no k, so it's 0, 0. That helps me with my vertex, which is a, because my vertex is 0, 0. So I can go ahead and actually put that on my graph right now. Here's my vertex, 0, 0. All right, what about the table? Well, that table is going to be based off of my pattern, my output pattern, that I go ahead and discover. Normally, it's 1, 4, 9. Why is that a normal 1, 4, 9 pattern? Well, look at my table that they give me. The reason my pattern is 1, 4, 9 is because 0, 0, here's my vertex. If I input 1 into the function, 1 squared is 1, so my output is 1. If I input 2, 2 squared is 4. 3, 3 squared is 9. So here's my normal pattern, 1, 4, 9. Going back this way should be easy because my pattern should repeat itself, but going the other way because parabolas are symmetrical. So 9, 4, 1, 0, 1, 4, 9. I have all my points, and I could graph according to that. Well, the pattern here, I take this pattern, this normal output pattern, and I multiply it by my multiplier, my a value. Well, it doesn't change anything. So my normal pattern is 1, 4, 9. So write 1, take your pencil, write 1 up 1, write 2 up 4, write 3 up 9. Graph that half of my parabola, mirror it over the other way. Over 1 unit, over 2 units, over 3 units. There you go, that easy. There's 13. Now, when we get to 14, okay, read the directions to yourself. 14 is asking what? What is 14 asking? It's saying what value of w will give me 2 x-intercepts? Well, think about it. If I look back at, and I really wish I could have both of these on the same graph here. I'm gonna try. That'll help a little bit. If I look back at my parabola, which way does it have to shift in order for this to have 2 x-intercepts? It has to shift down. All right, but when you look at this, you look at x squared plus w. What is w? I don't know. What does w mean in the context of the problem? W takes the place of k. Why they chose w, I have no idea, but they chose w. W is k for the context of this problem. So the parabola would have to shift down, so therefore w has to be a number less than 0. Any number less than 0, any negative number, in other words, would make this work. 15, I want 1 x-intercept. All right, if I go with 1 x-intercept, okay, how does my parabola have to shift? Well, let me ask you a question. How many x-intercepts does it have now? Before it shifts, how many does it have? It has 1. So does it have to shift? W must be equal to what then? W equals 0. Okay? 16, question 16. I want 0 x-intercepts. If I want 0 x-intercepts, how does this have to shift? It has to shift up. Up would give it 0 x-intercepts. What is up? Up is a w greater than, not less than, greater than 0. In other words, any positive number. What about 17? Well, what's happening with 17? Keep in mind, now that we're all done with these, okay, I'm gonna get rid of these just so I can save some space. Keep in mind, my normal parabola is here, opens up, right? How is this changing? How is 17 changing? 17 says minus x squared. So 17 is for a parabola that opens down. So here's my focus. No stretch, no shrink, because it's A. I want 2 x-intercepts. W has to do what? What does W have to do? Well, for this to give me 2 x-intercepts, W is K, remember, has to move up. Okay? So W has to be a value greater than 0. 18, I want 1 x-intercept. What does W have to be? Does it have 1? Because if it moves up, it's going to have 2. If it moves down, it'll have 0. So W equals 0. Okay? Or K. I could say K. It's the same thing. And then 19. You should be able to think about this. I want 0 x-intercepts. What does W have to be? 0, 0, 0. It's got to shift down. Shift down. W has to be a number less than 0, actually. Not less than 1. Less than 0. Okay? In other words, it's got to be a negative number. Okay? The last thing I want to talk to you about, well, actually, there's 2 other things because I want to fit in the go as well. We're going to do that in class. The last thing I took a poll today in class, and 22 to 25. Most of us thought that 25 was the most difficult problem. Since most of us thought 25 was the most difficult, that's the one we're going to look at. We're going to look at y equals minus 0.5, x plus 1 squared plus 4. We're going to walk through the process that you should walk through every single time you graph a problem according to vertex form. The very first thing I want to do is I want to look at this problem and identify, gee, what form is it in? Vertex form. Okay. I'm going to graph it, can I? How do I look at this form and what does it tell me? What is my A value? Well, my A value is negative 0.5. What is my H value? Well, gee, my H value is minus 1. What is my K value? My K value is positive 4. Now, some of you might be sitting there going, thinking, well, Mr. Wilson, your H value is wrong. In the equation, it says plus 1. You have to remember, if my vertex is here in the middle, and this says x plus 1, it causes the graph to shift to the left. It's not wrong. It looks wrong, but it's not. Therefore, my H is a negative 1. So I identify the vertex. My vertex is negative 1, negative 4. I know I'm going kind of fast. If you need to, pause. Okay. The last thing I need to do is look at my output pattern. This is the hard stuff. All of this is the hard stuff. But if you can get this, it's easy. My normal pattern is 1, 4, and 9. But because I have a multiplier, that pattern's going to change. Well, how's it going to change? It changes based on how my multiplier affects my output, my normal output values. In this case, I've got to multiply 149 by negative 0.5. So what are my new output values? Well, what is half of 1? That is 0.5. Half of 1 is a half, but it's a minus. What is half of 4? Negative 2. What's half of 9? Negative 4.5. So here's the new pattern, the adjusted pattern that I'm going to go with. I plot my vertex, negative 1, positive 4. There's my vertex. I might even identify my line of symmetry, which I like to do because that's helpful. You'll see where that's helpful in a moment. And now, take your pencil, put it on the vertex, and we're going to move right 1 and down, not down 1, but down a half. Okay? Here would be my right 1, down, not 1, but down a half. Right here. Right 2, down negative 2. So right 2, down negative 2. And right 3, down 4.5. So over 3, down 4 would be to the x-axis, down another half. There. And that should make sense because a multiplier of 0 to 1 causes that parabola to stretch. Now, the reason why I put the x-axis or the axis of symmetry here is for this reason. Okay? it's easy for me to keep track of how far and where things are on the left side or the right side, depending on how you do this. So I have one point there, I have another point here, and I have another point over here. Boom, there. There's the other half of my parabola. I want them symmetrical. If I don't draw, for me, if I don't draw the axis of symmetry, sometimes I end up with a parabola that may look like this. Okay? I get this side here, and I got the axis of symmetry, and maybe my parabola looks kind of like this. That doesn't look symmetrical. So for me, I always draw that axis of symmetry. Imagine that not being there and it looking like that. No, that just doesn't look right. So again, that's why I draw that axis of symmetry there. It helps me keep things symmetrical. All right, the last thing I want to talk about is I'm going to help you with 26. Okay, because I have a feeling that tomorrow in class we're going to work on the go, and you're going to include the set and go as part of your assignment. And I'm going to show you how easy this is. It's just use the table to identify the vertex, the equation for the axis of symmetry, and state the number of x-intercepts the parabola will have, if any. State whether the vertex will be a minimum or maximum. This is going to be easy. So it gives you the table. I'm sorry I didn't write the output values in here. 10, 3, -2, -5, -6, -5, -2. All right, so from the table, how can I identify the vertex? That comes first. Well, remember, parabolas are symmetrical, so I want to meet in the middle. 10, 10, no 10. 3, 3, no 3. -2, -2, -5, -5, right here. Here's my vertex, 0 and -6. What is the axis of symmetry? Remember the relationship between the axis of symmetry and the vertex? I'm going to say x is equal to 0. Okay? Here is my x, here is my y. These two values are the same. All right? How many x-intercepts is this going to have? Well, watch. All I'm going to do is I'm going to draw a quick reference guide, a quick graph. I'm going to plot 0 and -6. And look at these values. Are -5, these values on either side, are they larger or smaller? Because if they're larger, that means my parabola is opening up, which tells me I have 2 x-intercepts. And it's going to be a maximum or minimum. In this case, it's going to come down, minimize, and go back up. There, that's it. That's how easy 27, 28, and 29 are going to be. They're going to make you think a little bit. Ask questions.